Okay, hello class. Today's lesson is on beam architecture. We have three different ways that we can do these beams and rafters. We want to show you each design and the pros and cons. We have a little mock-up here, as you can see. Here's the beam. It would, of course, go all the way across. The first beam would probably be very close to this wall, and then it would work its way across as we discussed. This gray rafter is a 2x6. We will be adding these to the roof line because the roof line just has 2x4 rafters, and we want a little more space for insulation and strength. So the way this one is connected here in the corner, this 2x6 comes down. The drywall would be on the bottom side of it, and then the beam here would appear to just disappear into the drywall. The drywall is made up with the drywall on the wall and come down, and then this beam would have some kind of molding around it to make it nicely go into the drywall. There's plenty of room from where the drywall would be all the way to the roof for insulation. At the very top, though, you can see that it just about touches, and we would only have the nominal 6 inches, of course slightly less being a plain wood, that would give us that much for insulation. But it would give us no room to have airspace. We had air vents down here in the eave. As the air tried to go upwards, it couldn't get out because we are touching the roof line at the very top there. But this would give us the maximum amount of visual peak space and make the roof at the very top look the tallest. But it definitely has a few drawbacks to it. We'll pause and show you the next design. Hey gang, we're back. Okay, so really no change down here, just an ever so subtle different angle. As we go to the top, you can see this one is now equidistant on the gap, so it's a constant same pitch as the roof, and that leaves us more space for insulation, or just filling the insulation at this 6-inch point and gives us space here for airflow. So if it is important to have a vent at the eave and then a vent at the peak at the top there, either a ridge vent or some other venting system, this would be something we would want to do. At the peak here, you can see it's down just a few inches. I don't really think anyone would notice that the drywall wasn't quite as high. So by having the apparent interior ceiling be just a few inches lower, we gain a lot of advantages of working up here. This even gives us enough room maybe to spray a little spray foam underneath here and still have an air gap, and then fill this with batt insulation. And now we'll do another design. So a slight continuation of the number 2. Terry is up there holding it. You have a 12-inch gap where, Terry? Angled to the side?
From here to here is 12 inches, and it's about a 6-inch, 5 or 6 inches here.
Okay, and so now, leaving the left side alone, Terry's just going to drop that down.
About 16 inches, and then you have 12 inches of free space.
Okay, that would be if we wanted some heating or air conditioning ducts at the peak running along, if we needed that much room. I just wanted to show what it would look like if we were somewhere from number 2, I call that number 2A, if we needed a lot of room up there at the peak to do things. Okay, I'll pop. Okay, another subtle change. This is number 3. You see over here, this beam, which you've seen previously be very close to the ceiling, has just been set differently. So now the sheetrock comes down and does not, it's just different right here. Review the earlier part of the video. Previously, this crossed over some of the beam, and now being up here, this beam would be completely exposed until the very corner. Then sheetrock would be going up, sheetrock would be going across there. We simply added this to show you how the sheetrock line would look. This would be covered in sheetrock, and it would simply go up, hit here, and go up. And then right here, we'd have a nice trim. And so this shows more of the beam. It's just a different way for the beam to disappear, and I think it makes the ceiling look taller, because it is taller. The challenge is that this is right up against the roof rafter all the way up, and so we only have 6 inches for insulation. There's no way to put any airflow in, which is certainly not required, and especially not necessarily for an apartment, especially if the apartment is really well insulated with 6 inches. And so the disadvantages is no way to do that airflow. We're currently not showing any space at the roof. Certainly, I guess that could be brought down if we wanted to leave a little space at the top there. We would simply have a shallower angle here. We're not going to show you that. It's pretty obvious. But the advantage of this one is a different kind of corner where this is taller. And you see more of the beam. And it goes into the wall with a squareness. When this was lower, it went into the wall at an angle, so to speak. The drywall was at an angle. So that's number 3.